All right, let's say we have x squared plus 5x equal greater than or equal to 0. All right, so x plus 5x greater than or equal to 0. What we could do in this is that we can actually factorize to solve. So we're going to factorize the left side here. X is our highest common factor. So x into x squared, we have x. X into 5x, we have 5. Greater than or equal to 0. Now, we're going to find some critical values, right? Critical values. So we have some critical values here. One of our critical values is that we have to say either, all right, so either x is equal to 0, which is one of our critical value, or x plus 5 is equal to 0. So this will make x equal to negative 5. We subtract 5 from both sides, subtract 5 there, subtract 5 there. So here it is, we have two critical values. We have two critical values, all right? One is x equals 0, and another one where x is negative 5. So what we have is we're going to go on the number line, all right? We're going to have to go on the number line now with these. So on our number line, we have, say, 0s here, we have negative 5 here, and this would have gone to infinity, negative infinity there, and this would have gone to infinity, positive infinity. We're going to have to test here between, we're going to have to test between these. All right, so here we have two values. We're going to have to test what's going on between here, what's going on between here, what's going on out here. All right, so we have to go in the three different regions, pick up a number within there, and we're going to try about that in the system that we have to see when those numbers are actually greater than 0, because this should be greater than 0, as you could see here, which means we're looking for a positive number, because positive numbers are greater than 0. Now, what are the numbers that we could test in this region? We have here any number less than negative 5. So we're looking at, I could just test negative 6 from this region. From this region here, I could just test as simple as negative 1, and go in here, I could test 1. Now, these are a part of our solutions, and the reason why they're a part of our solutions is because we have equal on our inequality. Equal. So as you could see, it's greater than or equal. So these would be a part of the solutions when we do find the section that we're looking for. Okay. All right, let us check some of the values that we have right now. We want to check to see when we have any number that will be positive in these sections. So let us quickly check using this. We're using x to x plus 5 greater than or equal to 0. So when x is negative 6 here, we're going to put negative 6 where x is to see what value we get. Negative 6, then we have negative 6 plus 5. Well, you could see this is negative 6 here, and this is going to give us a negative 1. And negative 6 times negative 1 is going to give us a positive number. It doesn't matter the size of the number, it's just that it's a positive number. So that means in this region, we got a tick here because we do get a positive number in this section from negative 1 going that way. All right, let's check negative 1 here. From negative 5 going that way, my bad. From negative 5 going to negative infinity, we got a positive response, which means that that's what we're looking for. Let's go between negative 5 and 0. We're going to use 1. So let us use 1. So x into x plus 5 greater than or equal to 0. X is negative 1. Negative 1, negative 1 plus 5 greater than or equal to 0. Let's see. This is negative 1, but this is a positive 4. And then when we do work out this, this is going to give us a negative number. All right? So that means we have a negative number in here. This is not what we want. So between negative 5 to 0 is not what we're looking for. Let's look at the last test. Anything out here? All right? So we're looking at x plus 5 should be greater than or equal to 0. If x is 1, so x is 1, we're going to try 1. We're going to try 1 there. 1 plus 5. When we check this out, this number is positive, and this number is positive. So definitely we're going to get a positive response from that. So we do get a positive response in this area, which is good. So let's go to the next page to see what's going on. All right? All right. All right. So we did have negative infinity. We had negative 5. We had 0. All right. So the numbers we test, we got positive in this section. We got a negative in that section. We got positive in that section. Remember that responses here at negative 5 is a part of our solution because the original thing had greater than or equal to. If it is greater than or equal to 0, then definitely the number is positive. How do we represent these? Well, we can represent this using inequality by saying, right, here are our responses. We have where x is less than or equal to negative 5. That's one of the answer. Or we're looking at a case where x is actually greater than or equal to 0. That's another one of our responses. So we got 2 responses for that. And using that. So we could have represented this with a compound inequality if we wanted. Let us say that we were representing this using interval notation. Interval notation would have had negative infinity here, negative 5 here. We would have this here, that, and then it's going to be the union, right? And then now we would have 0 here, we would have positive infinity here, all right? And then we would have that there and that. So this would have been, the second one is interval notation here, and the other one up there would have been using inequalities. All right, thank you for watching this video, and I hope that you learned something.